Hi, I'm Anastasia, and apparently I'm a mother. I didn't know that. So I would say that there are two levers that, as a society, we're not doing a good job of pulling right now. One is identifying and building fundamental capabilities, and one is identifying and building the institutions that we need to make those capabilities. Okay, imagine technology as a tree, where at the end of that tree we have the applications that we interact with in our daily life, vaccines, medication, your smartphone. As you go back down that tree, you find the more fundamental capabilities that have enabled that downstream use that we're all benefiting from. So let's say that we want to better understand how neural nets could be building AI, or we want to treat neurodegenerative or neuropsychiatric diseases, or we just want to fundamentally understand consciousness. These are all in nodes in neuroscience. They're all blocked by having a brain map, so like a synaptic level map of what neurons talk to what neurons in the brain. So we need to build some mapping technologies. Actually, the really expensive part of building mapping technologies is proofreading. Right now, we think that it would cost something like $1 billion to map a whole mouse brain. That's just like no one's going to give you $1 billion to map a mouse brain. So what if we can make it cheaper? E11 Bio is working on that fundamental capability. This video is not going to load. Great. You guys saw some neurons yesterday. So they're working on this fundamental capability of building the proofreading capabilities that will then unlock many, many downstream applications. Why doesn't that happen automatically? Like, we know that these things are important. We know that these fundamental capabilities could exist. Turns out there aren't existing institutions and there aren't existing incentives to go out, identify what those capabilities are, and build them on purpose. You know, industry is looking to return funds to its shareholders. It's looking to align with corporate missions. Startups want to raise venture capital to be able to return an entire fund, so they're looking for 1,000x multiples. And academia is out there generating papers and doing discovery research, but not actually saying what is the most important thing I could and should be building. So I would argue that you should go out and find those fundamental capabilities, and then you should build organizations that do just that. Focused research organizations are an example of an organization that builds those fundamental capabilities. That's what we run. These are 5-year, $50 million R&D efforts. They're focused on a specific area of technology. We span right now everything from neuroscience to non-model organisms to single-cell proteomics. The idea being that we've been able to identify what we think are the biggest bottlenecks in a field and go out and build them. And I think that this is where philanthropy has an outside opportunity to work, right? If you are deploying venture capital, you do actually have LPs that you're responsible to. If you are in an industry, you are tied to those incentives. If you are in academia, you are tied to those incentives. If you work at the NIH, you have a bunch of internal incentives within your organization that you have to compete with for any one activity. If you're a philanthropist, you can actually take a step back and say, what is the most impactful thing I can do? What is the fundamental capability that I wish to have in the world? And then go out and build only that thing. There are a bunch of organizations that are working in this space right now. You can think of Reflective, which is working on solar radiation management. You can think about ARC, which is working on AI models for biology. You can think about Future House. All of these are organizations. You can think of what Josh is doing at Renfell. All of these organizations are new projects. They're meant to tackle a specific problem that isn't going to be solved within our existing ecosystem. And so this is how I would push people to consider philanthropy, as what won't happen without those philanthropic dollars. Yeah, so there are a couple areas that I would really encourage philanthropists to continue to look into. One is in biosecurity. I think that biosecurity is a big risk for humanity, especially as AI continues to progress. There is work from Blueprint Biosecurity on far UVC and metagenomic sequencing. We are working with ARIA right now in the UK to identify problems. We're potentially looking at a project that would genetically engineer coral reefs to make them heat resistant to bleaching events. We are working on neuroscience projects. And then there's a bunch to do in resilience around AI. So can we build the cyber resilience systems that we need to have secure infrastructure, to have provably verifiable software, and build sort of the safe future we want to see? Yeah, that's it. Thanks.
Questions, comments? I'll go in the back.
Do you think we know how to do this field strategy well yet? Or is this still sort of like an exploratory process that Convergent is developing?
So we definitely have some tools. So we do some scientific road mapping using a notion of like tiling the field. So in neuroscience, this is what happened, where you looked at like many different factors in that field and looked for a common underlying thread. We also do sort of a very bottom-up approach of asking people what they think the most fundamental problem in their field is. Turns out people often don't work on that problem because they can't in their incentive system. So it's actually pretty low-hanging fruit to go and have conversations with leaders and ask them what they think should be built. But I do think that there's a lot of work to be done on, and a lot of sort of benefit from building roadmaps and then publishing roadmaps, both in philanthropy and also then for government and federal funding. There's like really high leverage in just publishing what you think should be built.
What do you think is the biggest bottleneck to scaling this up 100x?
I think that like we're capital constrained. I think that like it is very hard to launch fundamental research problems for less than, or projects for less than like $30 million. And so to Eli's point, there's a bunch of other kinds of capital out there we can use. We could actually take for-profit investments, put it into a fund, and then use something called a convertible grant into our philanthropic efforts, or we can raise a philanthropic fund or get federal funding. So I think that capital constraint in these projects is a big one.
Even if you're scaling up field strategy?
I would ask Josh all about field strategy, because that's what he's doing.
So I was wondering, when you're sort of scouting for these types of focused research organizations that you're aiming to fund, what kind of starting point is usually expected for sort of getting to the point where a technology is ready to be expanded into a focused research organization? Do people usually do like a mini FRO first and then a full-on FRO, or is there like some kind of preliminary data that is usually considered essential, or does it vary depending on the situation?
We tend to spend something like 6 months with potential founding teams working on designing what our proposal looks like. Because I think that one of the big differences between an FRO and something like academia is that there's a very clear technical roadmap to get to where we want to go and a very clear product. And so spending time building that roadmap, understanding what those milestones will look like, understanding who would need to be on the team. So we do spend something like 6 months with most of our teams building out that process and that plan.
Got it. And do these prospective teams usually come in with existing technologies, or do they come in as like a clean slate?
Almost always, it's very founder-led. So it is somebody who believes, you guys all heard from Andrew Payne yesterday. He believed that this is the most important thing that could be done in their field. And so it's often with those technical founders.
Excellent. Thank you.
Okay, cool. Thank you so much. Yeah, thanks.